All right. Going to do a quick live stream here on how to model a platter or a sign in Fusion 360 using for the Shapeoko 3 as a way to just making sure this is posted out here. Just doing this as a quick tutorial on how to model something basic but functional. Just another example to kind of help people who are new to Fusion 360 and have a Shapeoko 3. So this is my basic desktop here. Man, I've been struggling with the live streaming today, so hopefully this is broadcasting and working correctly. Software is just not cooperating. Okay, so the first thing I'm going to do is I'm going to switch my units. I have it in millimeters for 3D printing. I'm going to switch it over to inches and say OK. So now I have my blank document here in inches mode. I'm going to pretend I have a 10 by 10 piece of stock from the store that I'm going to cut into a platter or a sign or whatever object it's going to be. This is kind of going off of an example that Deb in the Shapeoko group had, and she had done it in Fusion 360 first and switched to Carbide Create to do a logo on the bottom of it, and you can easily do it all in Fusion 360, so I figured I'd give a quick demo. First thing we always do is we create a sketch. So I'm going to click the Create Sketch button, and it's going to come up, and it's basically prompting me to choose a plane to sketch it on. This can be a little confusing. If I leave my mouse where it is right now, you can see that the plane that's in blue is flat. That represents your XY. Red would be X, green would be Y, and Z is sticking straight up from it. So that's the plane you're going to want, because this is how your stock's going to be positioned on your CNC. So I'm just going to click there. And then I'm going to come up here to draw a rectangle, do a 2-point rectangle. And the size doesn't really matter to start. Just draw a rectangle. I'm a fan of the dimension tool. If you hit dimension, click on the tool, it may be buried down in your menu here. Or you can just hit D and you click on a line and drag. You don't have to drag, you just if you click dimension, click on the line and then move your mouse to the side, it'll show you this dimension bar. And if you click, you can type in 10 inches and it will change the scale of that size to a 10-inch line. Do the same off the bottom, 10 inches. And I now have a 10-inch square that represents my piece of lumber. I'm going to hit escape, so I'm no longer on the dimension tool. That's all I want to do for now is just draw the square. So I'm going to click on the center of it so it turns blue. I'm going to right click and choose extrude. Or you could hit the E button for extrude. And I want to make it 0.75 inches tall. That's how big my imaginary piece of stock is. So this is what I went to Lowe's or Home Depot or whatever and got. Sorry, just checking a message there. So now I would go in and I want to, I use the same mentality that I would in thinking how the Shapeoko is going to cut this. So I now have my stock and I'm going to cut some things out of it. First thing I want to do is sketch on this top surface. And I want to cut a square out of here. Again, I'm kind of modeling the piece that was the example I saw from Deb. So there, I've drawn a rectangle and I didn't worry about the dimensions at all. I'm going to use my dimension tool again. I'm going to click this left line of the square I just drew. Click the left line of the side of my stock and drag down, and that'll give me a dimension. I can set that to 3/4 of an inch. I'm going to do that off of each side and set each one to 3/4 of an inch. Same off at the top. Finally the right. So now if I click on that, I have this nice 3/4 of an inch wide rim around the outside of my platter, my sign, whatever this is going to end up being. If I click on the center, then I can right click and choose extrude again. Only this time I'm going to do a negative 0.5 inches. So I'm going to cut that down, and you can see when I type the negative, the operation automatically changed to cut. If it doesn't, you need to go make sure it does say cut. You can see it's showing in red here that it's cutting down in. You want to make sure it's not doing a join or an intersect or a new body, some other thing. You want to say cut. Say OK, and it will cut that square down into the shape I have. So now I want to add a drawing to this inside of the bottom of that. So I'm just going to click on that so it's highlighted in blue. I'm going to say create sketch. Now I'm creating a sketch on this plane. I'm going to zoom into it a little bit. I'm going to go insert SVG. Select an SVG. I'm going to choose the Imperial Seal for Star Wars. And that's, you can see, sized a little bit bigger than I need it. So I'm going to go ahead and scale that seal down. Now I'm going to just drag that over and adjust it until it's the size I want. And then I'm going to center that nicely in my platter. And when it's a scale and location you want, you just say OK. What that's essentially done is it's drawn these, they're green lines, but they're the SVG onto that sketch plane that I defined before. So at this point, I can select the part of the geometry I want to cut into my platter or my sign, and right click and say extrude. And I want to extrude this negative 0.1, let's do 0.05 inches. And it cuts that down into that bottom surface. So now I have my object, and I could cut it. Now I see a couple problems here I want to clean up. I like fillets to round off those corners. My CNC can't do a nice sharp corner. So I'm going to select, actually, if you go modify and fillet, you can then click on each of those corners. And you can see as I click, this edges count starts going up. You just want to click each of the 4 corners. Again, shift and middle mouse button to rotate your view. Select all 4 of those corners, and then you give it a radius. Or you can just drag the mouse until it looks how you want. I want to do a nice 1-inch radius on this. Make it nice and curved, and say OK. Let's go ahead and add a outside corner radius here. Same process, modify fillet. Click each of the 4 corners. And then I'm going to just type in a 1 to give it a 1-inch radius on the outside as well. And if I click home up here, that'll switch me back to my default view. And there we go. I've got a platter, some logo I chose. It's the Imperial Seal in this case in the bottom. And nice rounded corners. So this is my object I'm going to cut in the Shapeoko. So go down to the CAM view. And when you switch to CAM, you need to go ahead and define a setup first. Your setup is defining the stock and the starting point for your model. That's all you're doing. Um, it's basically telling it where your 0 point is and how your stock relates to that. Our model orientation. It should be correct if you followed that z-axis and chose the right plane for your sketch in the beginning, but it's always good to verify it. So I'm going to change the orientation to select the z-axis plane and x-axis. For the z-axis, if you just click the top of your model, it will fix the z-axis. Sometimes you'll come in and your z-axis will be pointing off in some strange direction like this. That's where you really need to make sure that you click the top of your model so it's pointing up. For your x-axis, it's the same idea. You want to think of it as selecting the direction you want the arrow to point. So I'm going to select the right side face of it. And there we go. So I've selected both my axes. Now I'm going to choose a stock point. This is for your origin here, this last item. And so this is where you're going to position your end mill when you zero X, Y, and Z. So I'm going to choose this lower left corner right here for my stock point. And I choose the top of the model. That's where I zero things to. So if you picture your stock on your Shapeoko, it's laying there. I'm going to put my end mill against the very corner in the lower left of the stock, top corner. So that's good for this tab. The next tab over is your stock tab. Again, measure your stock. I assumed my model, I typed in 10 by 10 by 3/4. That would be actually what I measured. So in this case, I'm going to do a fixed box size. I'm going to type in it's 10 inches wide, 10 inches deep, and I'm in millimeter mode. 10 inches by 10 inches by 0.75 inches. Important that those values you enter actually match the size of the wood that you got. So don't trust the store, actually measure it and type it in. So once you've set your stock size, your setup is really done. Now we can start doing the cam. So the way I would tackle this project would be to start with a 2D adaptive clearing. And so 2D adaptive is great for clearing large areas. It's not a finishing procedure. It's just to clear a lot of material very quickly, and it makes a good use of the end mill. It's very nice on it. So I click 2D adaptive. First thing you want to do is select your end mill. I have a carbide 3D 1/4 inch flat. That is probably my best end mill for doing this. So I'm going to say OK. Coolant you can ignore. Carbide 3D does provide feeds and speeds. For this, I looked them up. If I was doing this in Pine, they recommend 21,000 RPM. Again, I'm in millimeter per minute. That really doesn't matter. My cutting feed rate, they recommend 75 inches per minute. Lead in, lead out, 60 inches per minute. Ramp would also be 60 inches per minute, and plunge would be 33 inches per minute. Or I think they say 40. So there's my feeds and speeds. Those are all the ones I worry about. The important ones are the cutting feed rate, your lead in, lead out, ramp, and plunge. And general rule of thumb, my cutting feed rate, if whatever that is, my ramp is roughly 60% of it or so, 2/3 of that. And my plunge is roughly 1/3. In this case, I'm a little bit higher just because I'm going with what Shapeoko says, or Carbide 3D says. Click your geometry tab, and important note here, don't click the face you want to cut down to. You can get some weird effects when you do that. You want to click the lower outside contour point, this line on the outside here. So once you click that, you should get a nice blue area here, and this is what it's going to clear. For now, I'm going to leave it just like that. And I don't even look at the other tabs at this point. I just say okay and see what kind of cut it's going to give me. So it's generating an adaptive, and it's clearing that pocket just like I would want it to. It's not, going out through the side or something like that. So this is pretty much what I want it to cut. Now let's go back and edit this, and we'll fine tune it. The heights tab, if you're not using clamps or anything, the heights tab is probably fine. It's going to set the top and bottom to the contours in question, the stock top. It's going to retract over the stock top, and it's going to have a clearance height above that. So generally speaking, that's fine. If you have clamps or something that it needs to retract over, you may have to increase that retraction height is the one to watch for. On the passes tab, this is the important one, and there's a lot of information here. For adaptive, I usually use the same settings. I leave some radial stock. I turn off axial stock. It does a good enough job for me. On the axial is what's highlighted in blue here. It's the bottom plane. Adaptive cleans up the bottom well enough that I just leave that alone and say 0. Radial adaptive will do a horrible job along this outside edge. It's not a finishing pass for that. So always leave a little bit, half millimeter or so, or a couple thousandths of an inch, that you can go up and clean up later. Tolerance and all this, you don't need to worry about. The optimal load, though, is important. So what I do for an optimal load, I use a program called GWizard to calculate that, but generally I found that if I'm using a 1/4 inch end mill, a good optimal load is a 0.120, so just less than half. I do the same thing when I go to my 1/8 inch end mill. I go to just less than half for the load. Works pretty well. And you do want to set multiple depths. And again, this is coming from Carbide 3D. They recommend a 0.4 inch depth. I do need to make sure to type in inches here. And then I always click order by area, even if there's only one area, just to make sure that's what's checked. On the linking tab, there's a lot of things here about how it's going to do retractions and a lot of customization you can do. As long as the ramp type is set to helix, generally the defaults on this tab are just fine for me. So I'm going to say OK, and it'll generate my toolpath. I can click simulate, make sure stock is selected. I set toolpath selected, but set it to mode tail, and hit play. I'm going to speed it up a little bit here. And you can see it's going to go through and clear this pocket out. Now you can see that logo peeking through. That's not really there. If I turn off the model, it's not doing anything with the logo. It's going right down to that height of that pocket, and it's stopping there. So I get a nice clear of the pocket at that point. Turn my model back on. So to save myself some time, I'm going to go ahead and copy this. So I'm going to right click on it, and I'm going to go down to create derived operation, 2D milling. I'm going to do another 2D adaptive. And it opens up the window for me. I'm going to come to this geometry chain here. I'm going to click the X by it and get rid of that. I'm going to come in, I'm zooming way in so you can see. I'm going to click the bottom edge of this pocket here. Now, 2D adaptive is not very smart. It will not recognize there are islands here. It'll cut those clean off. So I need to go through and select each of these islands in the center as well. And again, I'm choosing that bottom edge on each one. You don't want to choose the top surface. You want to choose that bottom edge. So if I choose that on each of those, say OK. It'll use the exact same settings, which are fine. It's all I need. It'll clean out the bottom nicely and use the same tool, same settings. So it's just generating a nice toolpath. Now you can see it can't get in between all of these little areas here. That's all right. This is just clearing out the bulk of the material. And if I come back up and click on Setup and Simulate, and I speed it up, it's going to do first the outside pocket. That's depth 1. It's going to do the second depth. I'll go ahead and turn off the model here. So there's my 2 passes on the main pocket, and now it's going to go through and do as much of the logo as an adaptive strategy can really clear. And it's got that same setting. It's going all, full depth, but it's leaving a little bit around the contour. Turn my model back on. Now, I want to come back up here to this first adaptive, and I want to do a create derived operation, 2D milling. I want to do a 2D contour. Now, when I do that, it's automatically going to select that same geometry for me again, that first contour I did for the adaptive. So that's exactly what I want. I want to come over to passes. I'm going to turn off multiple depths. I want to do a single, this is my finishing pass. I want to make sure stock to leave is not turned on. I want to turn that off. I always do that for my contours. Say OK. I want to click on this second adaptive. I want to do the same thing. Create derived operation, 2D milling, 2D contour. Contour 2. Geometry, it has those same islands selected I did before. I want to come over to passes, turn off multiple depths, make sure stock to leave is not on. Say OK. And you can see the tool path for that. It's going to walk right around the inside, and it is going to be able to cut inside of those little notches. So this tool, I don't need to do a tool change or anything, will work. And then the final thing I'm going to do, and this you got to be careful for. If you actually got a 10 by 10 piece of stock, this works fine. If you're cutting this into a larger piece of stock, you would need to do like a ramped contour or something. But I'm assuming my piece of stock really is this size. We can actually go back up to this first 2D adaptive, create derived operation, 2D milling, and I'm going to do a 2D adaptive. But for this one, I'm going to go to geometry, click the X. I'm going to click my outside contour. That will tell it wants to cut from the outside all the way out to the stock. Stock to leave is on, which is good. I don't want this to be my finishing pass. And I will go through and generate a quick tool path. And let's simulate just that one. And you can see because I selected that organized by area before, it's staying on each corner. If you don't choose that organized by area, you'll waste a lot of time retracting as it goes from corner to corner. It'll organize by depth by default. So this will take those corners off. Close that. And then I want to right click on that 2D adaptive, create derived operation, 2D milling, 2D contour. And make sure it has the geometry selected. I'm going to turn off multiple depths on this. My end mill can do, maybe I should leave that on probably. The stick out of this end mill is 1 1/4, but I think the max cutting depth is 3/4, so I probably do need multiple depths. So I'll leave that on. Oops, I canceled. So create drive operation, 2D milling, 2D contour. Multiple depths is on. Stock to leave is off. Say OK. And if I come back up here to setup and simulate the whole thing, play. Turn off my model. I always turn off the model because it can hide problems if you leave the model on. Cleans up all the corners and it's good. So at that point, I've cut my platter and everything looks fine. I'm going to go ahead and at this point I would click post process. You want to select your folder, give it a name or call it platter. Make sure in your configuration here you have Carbide 3D selected and hit post. Now I'm going to give a quick example here of if I wanted to round these corners off. I do have a 1/4-inch ball end mill from Carbide 3D. So I'm going to click back up to my model. I wouldn't want those corners quite so square, but it would be a lot of sanding to round those off. So if I was going to do that, I would go modify, fillet. I'm going to just choose those two top corners and this inside corner, all three. I'm going to do a 0.25, 0.15 inch. And that gives me some nice rounded corners. If I come back down here to model, or to CAM, I have to right click, generate toolpath, and it'll go through and regenerate all my toolpaths. Now it has two that have issues. If I right click and edit this adaptive, when I look at it, the geometry that I had before is no longer there. So I'm going to click the X on that. I'm going to click two places here on the geometry. I'm going to click the bottom edge of that rounded corner. I'm going to click the top edge of that rounded corner and say OK. And that kind of separates that pocket into 2 points and leaves that little step of a corner only. So the adaptive should be much quicker to clear the bulk of that, and I can use the ball cutter just for that little corner. And then come down to this contour, edit, geometry, and again I need to close that chain. And for this contour, I'm going to choose the top edge of that corner. Say OK. So now I have my same setup, and I'm going to hit simulate, and I'm going to jump all the way to the end here. And it's a little hard to tell with the colors and everything going on. I'll turn off the model, but you can see it's squared off. So it's cleared those two pockets I've now defined, and it's left a squared off edge. And obviously my top edges are still squared. To clear those, then you can leave the same setup. I'm going to create a 3D operation. So now I have to come in and say new. You can't do a derived from 2D to 3D. It can't copy the settings over. So I'm going to do a 3D contour. Under 3D contour again, you would want to input your same 75 inches per unit and copy the rest of your settings on down through for this. And select, and I want to go to Carbide 3D, select the 1/4 inch ball nose end mill, and say OK. So now I'm using ball nose end mill. All the 3D, anything in the 3D CAM operations is going to be for when you use that ball nose end mill. Geometry, this is where you're going to select, okay, so I'm going to select the bottom edge of this contour and the top edge, and it's going to highlight them both in green. And you can actually do all 3 contours at once. So I'm going to do from there to there, and from there to there. So I've chosen all 3 of my rounded contours that I'm going to do. And I don't need to check anything else in geometry, my tool containment. All right, that's all. The defaults are just fine for this. Heights again are fine. I'm going to go over here to passes. And this is where the fine tuning is done for your 3D operation. Your default 1 millimeter step down is still a really rough operation. You're going to want to lower that 0.5 millimeter. Translate that into inches. And you want to make sure order by island is definitely on for this. You don't want to be retracting back and forth between the 2 or 3 areas in this case. And say OK. And so now you can see it's built a contour. Oh, it's actually decided to walk all the way down that line. I may not want it to do that, but that's fine for this example. You can see it's only doing 2 passes on this top here. That's what the blue lines are. It's probably not quite enough. So let's go ahead and break this up. Let's make this a little more efficient. So I'm going to come into geometry. I'll unselect. Click those contours and click delete. I'll just make this 3 operations. I'll say OK again. So now it's cutting, okay, it's walking that inside wall. And it's going all the way down in 0.5 millimeter marks. And let's make sure, yeah, stock to leave is off, so we should be good there. I'm going to go create derived operation contour. I'm going to select geometry, get rid of those chains, select these 2 chains. Now, on those inside corners like this bottom one here, you don't generally need as many step downs because the end of the ball nose is really going to do the work for you. On these top rounded edges, that's where you need more step downs that I've found. So I'm going to change this to 1/4 millimeter per pass. And in this case, actually, I should be able to come back to geometry and select these outside ones as well. If I say OK, we're still only getting 3 step downs per. So I may want to even go a little finer than that and say like 1/10 millimeter might be a little too aggressive. Let's do 0.15. No. Go back to 1/10. It's really not stepping down this very well here. What am I missing? I have flat area detection on. That's probably it. So I set the machine shallow areas on. the maximum shallow step down has to be lower than the maximum step down. So I'm going to set that back to 0.15, set this to 0.1, and say OK. Now it's going to draw those chains, and it should, no, it's still not wanting to go the full distance down. Turn on some smoothing and see if that helps. Sometimes you just, with this 3D stuff, it takes a little playing to, we can see what it's going to look like here if we skip to the end of it. It's really not taking enough stock off. It could do a lot more. Just looking through to see. It's got to be something in this passes tab is not quite quite fine enough here. Go much finer on my step downs. I haven't done a lot of the 3D milling yet, so it's definitely better. I'm not still not sure why it's not getting lower into that curve, but let's see what it looks like if we run through the whole setup. So we'll skip all the way to the end here and see what our finished view looks like. That's really not too bad. You can see it's cut a good bit out of our stock. If I turn off the model, there's really not much difference between the two. So that'll take a little bit of sanding, but isn't too bad. And again, playing around with those settings, you could probably get that finer, but that's down into the weeds and the detail there. So at this point, when you do your export then, you would want to break it up into, these are my 2D operations. Select all of those. So I select the top one, hold down Shift, select the bottom one, and post-process those as one file and give it a name, something that indicates that's the one with the flat end mill. Then come back and click on the ones with the ball end mill, post-process those, and save those as a separate NC file. Don't save them all as one, in my opinion. You can do a tool change, but it's much cleaner to just do 2 runs, because then you can reset your Z-axis, change your end mill, reset your Z. Don't zero your XY, just your Z. Balance it back off to one of the top of the stock, and then just start the second job from there, and it should run and clean it up. So hopefully this is helpful. Take you through everything. If anybody has any questions, hit me up on either the YouTube comments or on Facebook. Hope this helped clarify some things on Fusion 360 and how to use it for your Shapeoko.